This video will show you how to manipulate sets in APL. Sets are lists or vectors. They are lists of items or vectors of scalars. Here's an example of a few sets. The vowels contains 5 elements, ABC contains 26 elements, and prime 10 contains 10 numbers. They're not characters, they're numbers. Items are a scalar. A scalar is a single item, an object without a shape, for example, the character A or the number 12. In APL, we use row, the function shape, to find the shape of an object. For example, here we have an item. If we ask for its shape, APL shows nothing. It has no shape. There are a few special sets in the set theory. The universal set, denoted by U. The complementary set, denoted by apostrophe, as in U apostrophe. And the empty set, which is represented by the Danish letter U, which means that there's nothing in it. It's a set which has no elements. APL has some basic set functions. For example, epsilon, which represents the membership function, or member of, if you wish, and tilde, which is the logical not, or negate. So if you wish, for example, to know if X is member of A in APL, you simply type X member of A. So if we have the set of vowels, these 6 vowels here, and we want to know if the letter A is member of the vowel set, it is. If we want to know if the letters A, P, and L are members of the vowel set, we can see that A is member, P and L are not. We can reverse this condition and say that we want to know where they are not member of the vowel set, and the result is reversed. If we want to know how many vowels we have 6. If we want to know if the set number 1 is member of the vowels, we can see that S is not a member, O is a member, M is not a member, A is a member, and so on. The set functions. The set theory functions are membership, cardinality, complement, union, intersection, subset, and a few more. Those are the basic ones. Membership is represented by the symbol epsilon in APL. Cardinality is represented by the symbol rho, or the function shape. Complement is represented by the symbol tilde. Tilde, or complement, can be defined in terms of epsilon and monadic tilde. We have to make a difference between dyadic tilde and monadic tilde. Monadic tilde is the negate function, whereas dyadic tilde is the complement function. So the complement function, as we can see, A minus B, is defined by all the elements of A not in B. So is A member of B? Negate that, and pick all the elements that are not member of B. Here the graph shows us the two sets A and B, and A minus B is this area here. In fact, nowadays all modern APLs use the dyadic version of tilde as a complement function. If we want to remove from S1 all the vowels, we can use the dyadic function without, represented by the tilde symbol. We use it dyadically, and we get all the letters that are not vowels. Union can be defined in terms of membership and tilde also in APL. For example, A union B can be defined as all the members of A catenated to all the members of B not in A. This looks pretty much like the one we had here before, the complement. So it's A and the complement of B in regards to A. So it's A union B. If we want to have the union of the two sets, that is all the letters in S1 plus all the vowels that were not in S1, we can see that so many letters from the S1 set is still there, plus the letters I and U, which were not there. Intersection can be defined in terms of the membership function in APL. It's basically all the elements of A that are in B. So all the elements that are not in B are excluded, all the elements of B that are not in A are excluded. We only keep the ones that are in both sets. If we want the intersection of the two sets, in other words, only the vowels that were in S1, we can see that O, A, Y, and the two letters E were in S1. Notice that you can have the same letters twice. There's nothing that says that we cannot have the same elements in a set twice. Subset can be defined in terms of membership and the function AND in APL, so that A subset of B is defined as are all the elements of A in B and are all the elements of B in A. In other words, all the elements of A must be in B and vice versa. If we want to know if all the letters in S1 are vowels, we can see that it is not true. If we want to know if all the vowels are in S1, we can see that it is not true. And we can check that condition to see if both are true, and it is not the case. We can create a second set based on the first one and verify that is S1 all member of S2 and is S2 all member of S1, and we can see that it is true. We can create a function that says the function will be called match, and we want to know if all the elements in the right hand set are member of the left hand set, and if all the elements in the left hand set are member of the right hand set. And we can use that function to see if S1 matches S2. We can see if S1 matches the vowel set, and it is not true.